Hi, my name is Connor Harper. We're the co-founders of Ion by Ion Technology, where we're reimagining the field of mass spectrometry. So let's talk a little bit about a problem in mass spectrometry that's becoming more and more important. The problem is simple. High mass analytes are hard to weigh. An example of it is shown here. This is the HRVA2 common cold virus. The top spectra, which by the way the x-axis here is in mass to charge ratio, this will be important later, is just an empty capsid. It's just the shell of the protein, no DNA inside. If you look at the data, you can see we have a big lump, but there's a spikiness to this lump. Those individual spikes or peaks correspond to charge states, or collections of molecules with the same number of charges. If we have these peaks resolved, we can figure out what those charge state numbers are, as we've done here, and in doing so, have the second piece of information we need to measure the overall mass of the molecule. We can times m over z by z and get the mass. However, on the bottom spectra, which is the native virus, so now with the actual DNA cargo, the real deal, we've lost this resolution of these peaks. We just have this lump, or sometimes we call it in the industry, the lump of death. There's no charge state resolution, and as a result, we can't make a mass measurement. And this is a major problem confronting conventional mass spectrometry techniques. Just to give you a measure of that, conventional MS techniques are usually good to about 1 million mass units, give or take. However, there are lots of interesting analytes out there, especially in the fields of biomedical research, biochemistry, and chemistry, where the analytes are larger than that. Gene therapy vectors, lipoproteins in cholesterol research, viruses, vaccines, pieces of the cell, organelles, and polymers and nanoparticles in material science. All of these things can weigh far more than 1 million mass units. But we have a solution. It's charge detection mass spectrometry, or CDMS. The mass range of CDMS is essentially unlimited, and we still have some overlap with conventional MS techniques, so we can check our work. How does it work? In our instrument, individual ions fly through a conductive tube. As they fly through the tube, the charges of the opposite sign. In order to get a better measurement, we can bounce our ions back and forth and ping pong with our ions inside of an electrostatic trap to get a better signal, more accurate measurements. And then at the end of the day, we get both an M over Z and a separate independent measurement of charge. By doing so, we now can go directly to mass. We don't have to use an inferred charge state in order to get mass information. We just have it. We have charge, we have M over Z, we have everything we need. A quick and great example of that we've already shown is with this big molecule over here weighing about 2 megadaltons. In the top spectrum on a conventional instrument, lump of death. On the bottom spectra, using our technique, CDMS, we found there were 2 distinct masses inside of that sample, corresponding to different conformers of this large molecule, which is very important information.
Customers will send us samples through local shipping or FedEx Air using local shipping boxes. We'll send back results as soon as we get them. Our business model is as follows. Our collaborators, which are people that are willing to co-publish papers for us using our machine, will receive a discount, while academic, research labs, and corporate labs will pay a slightly higher fee in order to justify the fact that they have the money. Here's our market size. Our total addressable market is $15.2 billion. This comes from the fact that there are 30,000 PhDs per year graduating in the fields of biochemistry, biology, and life sciences. And assuming each PhD works for an average of 25 years, there are 755,000 active PhDs per year. If 10 PhDs band together to form a research lab, there are 75,000 research labs in the USA. Assuming each lab uses around $200,000 per lab as analytical services fees, we have total addressable market of $15.2 billion. Our serviceable addressable market is just 50% of all of these PhDs in chemistry and life sciences in the US, which amounts to $7.6 billion. Finally, our initial target market is $376 million, 5% of all of these chemistry and life sciences labs. Here's our annual growth rate for the field of mass spectrometry, 7.3%. This is projected to last from 2019 to 2025. In addition, the compound annual growth rate projected for the field of electron microscopy, which is the neighboring field, is 7.4%, giving evidence to the fact that this is around the correct rate. Our competitive landscape is as follows. Charge detection mass spectrometry is a low-cost and fast analysis technique, as well as being very simple in sample prep and providing sufficient quality data.
Our team is myself, Connor Harper. My PhD research has been centered on increasing the capabilities of CDMS. I'm part of 6 published works on CDMS, 3 as the first author, and co-inventor on patented CDMS technology. My advisor and mentor, Professor Evan Williams, also advisor for Ion by Ion, is professor of chemistry at the University of California, Berkeley, the #1 ranked physical chemistry school in the world. He also is a distinguished author with over 300 peer-reviewed works and has extensive experience in the industry and in mass spectrometry. Finally, Albert here is a computer science major here at the University of California and has extensive experience in web design and user-facing aspects of business. Thank you for your time.